Well, hello everyone, and welcome to week 13 of CSC 120. So, this is the next to the last week of the class. Uh, you have made it. This week, we get into object oriented programming, which honestly, you've been using objects the entire semester. Everything in Python is an object. Most modern programming languages use objects as the basis for their variables and other items. So when you've been creating integers uh, or floats, those are objects. A string is an object. So in this module, we actually learn what that means. So before we get into objects, I wanted to talk with you about the uh, the way the class kind of finishes up. So after we cover objects this week, there is not an exam for module 7 of the class. Um, that module is covered on the final exam. So there is no separate exam for module 7. So uh, the final will be available next week. Most of the students in the class already have a grade of B showing. Very pleased with the way this class has turned out. So, what that means is you only need to earn enough points to get that grade that's showing above a 90 to have an A. So, your course grade that's showing in Blackboard is just a point total. It cannot go down. So I always have folks stressing when they get to the final exam, look at your course grade and know that even if you got a 50 on the final, you would still be adding 5 points to that course grade. The final's worth 10 points. So if you got a 50, you would add 5 points to whatever's showing as your course grade. Your course grade cannot go down, it only goes up. Also, if you have done all the Xylabs up to this point and you're happy with the grades on them, then you really don't have to do Xylab 13 because since the start of the semester, Blackboard has been set to drop your lowest project grade. Xylabs are projects, so now that if you have done 12 Xylabs, then Xylab 13 is sitting there with a 0 and it would be getting dropped. And so whether you do Xylab 13 or don't do Xylab 13, if you have done all the other labs, odds are your grade's not going to change very much. So, depending on, of course, your score that you got on Xylab 13. But if unless Xylab 13 happens to be higher than your lowest grade, then it would not really change your grade. So that's assuming that you've done well on Xylabs 1 through 12. So again, more good news for you. So what should you be focusing on if you've done all the Xylabs? You want to make sure that you do the CAs and the PAs for Chapter 10. You want to make sure that you do the final exam when it becomes available next week. And since everything is based off of objects anyway, and if you ever had any desire to do graphical programming in Python, GUIs and large scale programs use objects like crazy because it simplifies the way you work with large programs, and it also simplifies the way you work with GUIs. So if you're thinking that you might want to do things like that in the future, or might want to take the Microsoft Python certification, then by all means you'll want to do Zilab 13 even if it doesn't help your grade. So I've already done 2 videos uh, for objects, and here's the link on the checklist. If you click that, it's going to open up another page. This is actually in the folder for Module 7. And there are 2 videos out there that you can watch where I go through and basically walk through what's here in text and hopefully explain it maybe a little better than what the Zilab or Zybook does. But that material is also linked right here where it says textual walkthroughs. So this is what I'm going through in the video. And I also use some W3 Schools material right here. This is the W3 Schools material on how to create a class. And here's a very, very simple set of code that creates that describes an object class definition called myClass, and it's got one attribute that's called X. So here they actually they take this class definition here. This is the pattern to create a myClass object. Okay, here is where they instantiate an instance of myClass and name it P1, and then here's where they print the contents of that attribute named X, right, that has a 5 in it. So you can try that out. You will want to read about the constructor function here that's called _init because so much of the Zilab code has this in it, and they don't really tell you what this is until maybe halfway through the module. So you're going through this stuff and they're using it, but they never really tell you what it does. So I'm telling you, it's the constructor method. The constructor method gets run when an object is brought into existence, when it's born, so to speak. And so if you watch those videos, you'll learn all this stuff that I'm talking to you about right now. So back to the checklist here. Zilab 13 has to have an import guard down at the bottom. So what that means is you're going to have a class definition at the top, and then you're going to have an import guard down at the bottom before you start doing whatever they tell you to do, instantiating a instance of a student and giving it a name and so on. So just keep that in mind. They don't really I added some text to the Zilab so that it had the text out there that said you've got to have an import guard. They didn't have that originally. So all right, so let's go in and look at some of the material. I have in another window, I have actually gone into the Zybook chapter 10 material, and I've skipped over some stuff because at the start it's just kind of walking you through how class definitions and objects are used and getting you thinking in that mindset. So my purpose here is to get you a little bit of help with some of the challenges so that you can see how that works. So you'll want to make sure, if you have time, you can play these YouTube videos on double speed, by the way. I always, when I'm listening to myself, I think I'm talking too slow. And so I actually listen to myself if I want to check the videos over. I listen to myself at either 1.5 or double speed. If you just click the gear down at the bottom, you can change the speed of the video. So if you watch those things, you'll have a leg up on how to do some of this stuff in the ZyBook. Okay, so right here, what was I telling you about? They're going to be using that double underscore INIT double underscore. Okay, there you go. The very first example of a class, they're using it. So I'm telling you, this is the constructor method. It runs when we create an object from this class definition named time. So if you watch those videos already, you know that a class definition is the pattern or the blueprint for an object. So this right here that I have highlighted is a class definition. It's a pattern or a recipe that we would use to, if we want to talk about it as a recipe, let's just say it's a recipe to create some cookies, okay? We don't actually have cookies until we, take that recipe and start using it to make a batch of cookies. So, all right, so here is some example code. And again, what I'm highlighting right here in orange is the class definition. This is the pattern for a time, an object of the time class. Okay? So right here, this line instantiates an object. So when this line here is run, it creates an object named my time. My time. Okay? So at this point, we actually have an object in existence. It's alive. Okay? And then we can set one of its attributes right here. See where it says my underscore time dot hours? This is where they're setting that hours attribute. Okay? They're setting it to a 7. Now, let's talk a little bit about what happened here. When this line right here ran, it automatically runs the code in the constructor method. What I have highlighted in orange here is the constructor method. The constructor code gets run when an object is born or instantiated. Okay, whatever you want to call it. Okay, so this, if you'll notice, it says def. We were creating functions in the past, and def is the way we created a function. Okay, here inside of our class definition, this is how we create a method for a class. A method for a class. Okay? Every method of a class has to get past self. Self. What self is it is the actual entity, if you want to think of it as the soul of the object. The soul of the object. Okay? When we brought this object here into existence and it was born, my time has a soul, and the soul is in self. Okay? So if we brought another object in existence and called it myTime2, then the myTime2 object would be referred to by self when this code is run. So that's why I said it's self is a reference to the particular instance of the object. We can have more than one of these time classes objects in our program. Here they're only showing one. Okay, but look at what they did right here where they said self.hours. Okay, that's how we set the hours for this particular instance, my time instance. Okay, that's how we set the hours equal to 0. That's how we set the minutes equal to 0. Remember, these things get done when this line right here is run because they're in the constructor. Okay, and so after they changed those two attributes of that class, then they printed them out down here, and that's all they did. Okay, so I'm going to scroll down a little bit and get down here to this first challenge 10.2.2 where they're asking me to make a class, okay? Now, it says declare a class named patient data that contains two attributes named height underscore inches and weight underscore pounds, okay? And so it's going to have those two attributes. Now, they show you all the examples here where they're doing a constructor method inside of the class. I'm going to tell you that you don't have to put a constructor in there if that's all you're doing, okay? I'm going to do it both ways so that you can see that it works both ways in the Xilab. So where it says your code goes here, remember before we can ever use our patient data class, we have to define it, okay? So up above here, I'm going to do class and then patient data, okay? And then I'm going to go ahead and put a colon there. And I'm going to go ahead and do my height inches and weight pounds. So here goes. Height inches equals 0. Weight pounds equals 0. And I think that's it if I wanted to do it the simple way. So we'll try it. You can see all tests passed. Now I didn't do it the way the Zybook said. Now I'm going to change this class definition and put a constructor method in it, okay? Why did this work? Because when Python used this class definition, it created a class level attribute named height inches. It created a class level attribute named weight pounds. And that was all that they were doing in the constructor anyway. Now I'm going to put a constructor method in here so that you can see how it changes with that. This is the way they've been showing you. Okay. So right here, you notice I had to indent because these things are now part of the constructor method. Okay. Remember, I had to put self inside the parentheses. Now down here, I've got to do this because I'm inside of that constructor method. Self dot. Okay. Self dot. So this is the same thing, but it's a whole lot more code, isn't it? And if I run it, you see that it's still passed. So whichever way makes more sense to you, but I wanted to show you both ways. Both ways are not in your Zybook. Okay, so that's what it gave me for challenge 10.2.2. You may get something different, but that's what it did for me. Okay, so down here in this challenge that they're giving me to access the class attributes, okay, here they've got two attributes, item ID and quantity remaining, okay, and what are they doing? They're letting you key in stuff that gets stored into them. They want us to print these things out. So you could either use an F string to print them out, or you could use just a print statement. But remember, you're going to have to use the class name, not class name, but the object name. Excuse me. The object name is red_sweater. Okay. So if I wanted to get the ID, the item ID attribute, it would be red sweater dot item_ID. So that's the way I would get to that, whatever's in that. Okay, so I'll let you write that code down there because it's only 2 lines of code anyway. So instance methods. Okay, instance methods. So here it says write a statement that creates an instance of an animal called cat. So right here we know that our class definition, our pattern for creating an animal, looks like this. Okay, they want us to instantiate or bring an animal into existence. Okay, so name cat. So this is what I would do. Cat equals animal, okay, with the parentheses on the end of it. When you do this, it actually brings that object into existence. Now, keep in mind that you notice most class names here start with a capital letter. That's kind of a convention that they follow. It's not required or anything, but most programmers do that because class names typically are a noun, a person, place, or thing. Okay? Is an animal a person, place, or thing? It is. Okay? So when I check it, you can see I got it right. Okay? So scroll on down here and let's see if there's anything they need us to do right here. It says define an instance method for named INC num kids, okay, for the person info class, okay, that increments it, okay. So up here we've got to write a new method for this class, okay. Everything that's part of this class named person info has to be indented underneath it, okay. And you can see where it says solution goes here. So I'm going to def out a method, and the method name is going to be inc_num kids, okay. And this is what it's going to look like, but remember what goes inside these parentheses right here? Self. Okay? So now you notice how it indented me underneath that def, okay? Here, when a person is brought into existence, number of kids is 0, because that's what happens in the constructor method here, okay? So down here, if we wanted to change the number of kids, we could do it, but we have to use self to get to it. Self num kids, plus equals 1. Okay? That's shorthand. That's shorthand for doing this, right? Whichever way makes more sense to you. I like the shorthand way because it's less typing. Okay? So it said, define an instance of numKid, define an instance methods for numKids, okay, that increments it. Okay, so I think that's all that they wanted us to do. Let's see if it's happy. It is. So that's an instance method. Now just keep in mind as this goes on, they're going to have us adding parameters in here. Okay, self is always the first thing, the first parameter to our methods, okay? But you can put a comma in there and you can put other things. Okay? So, class and instance object types, okay? So, if we scroll on down here, let's see if it gives us, it didn't give us any challenge activity there, okay? So a factory for creating new class instances, okay? I think that's going to be this one right here. Let's see if I can get it to drag. There we go. Okay? So you just drag those down. I'm going to let you folks work with the rest of this. I did a couple of the challenges. Gonna scroll down a little bit more here. They've got an example of a seat reservation system, and right here, this is what I was talking about right here where I have highlighted. You notice that self is still the first parameter to every method, but this reserve method is actually taking in a first name, is taking in a last name, and it's taking in an amount paid, and it's doing what? It's setting some attributes for our seat to those things, okay? So, wanted to call your attention to that, okay? And down here, they've got some code that's actually creating seats. It's a loop right here that's going to go over and over and over, adding seats. So, class constructors, like I told you, they finally got around to talking to us about what the init double underscore is, okay? The constructor method. So they finally got around to telling us about it halfway through the material. So, class interfaces, okay? Usually, if you watch those videos that I did, you'll see how we use these interfaces, because in the Zybook, they haven't really shown us how to make things private yet. Usually you want your stuff in your class to be private. So here in this seat reservation, let's see, where is it? Got to go back one more. In the seat reservation system, what they didn't do right here for all this data that says first name, last name, and paid, in the real world, we would make all these things private, where somebody outside of our class here couldn't get to them, okay? And what we would then do is we would write methods, and the only way you could actually get to one of these things is through a method. The only way that you could actually set one of these things would be through a method, okay? Now, they are kind of doing that here, but since they did not make any of these things private, you could just go straight to down here where they create a seat. Where did they create a seat? Uh, let's see. Here, where they're creating a seat, they they could just go straight to, instead of calling the reserve method, they could actually be setting those things right here. So anyway, we'll go back down to the interface part, and again, if you watch the videos, you'll see what I'm talking about. But right here where they've got a def print time and print pace, these are what we call accessor methods or getter methods. This is a getter method. What it does is it lets us get to something, some of the data that's part of this class. Okay? And so I don't know if they ever show you how to make anything private in this ZyBook. I don't think they do. So anyway, when it's talking about special method names, the main special method that I've ever used is this one, this double underscore str double underscore method, because right here, if we print this truck object right here, if you don't define one of these, if you wanted to just try to print the instance of your truck object here, this is what you get. Not very helpful, is it? Okay. So it says instance at some memory address, just like it would do with a function. Okay. So the way you can make this print statement actually work is if you create one of these string methods, if you define one of these string methods. And right here where I highlighted in orange is where they did. You see they did a def double underscore str double underscore self, and then it says return, and it's going to return the name of the truck, cost, and its price, not for children under whatever. Okay, and then here, when we actually did a print on our truck object, you see what it says now? Monster truck XX costs whatever. Okay, so that's where you'd use a string method. Okay, as they go through this stuff, they actually show you how to override the greater than and the less than methods. They show you how to override the plus and the minus. I'll let you read through that. Here's some of it down at the bottom. I have not used that in the real world, and I've written a lot of Python code. So interesting that they're covering it. I guess they have a reason. Okay. And here's more talking about the numeric types. Here's where they're defining a subtraction override so that you could subtract two objects. So I could see where that might have some value. I've just never used it. Down here where it's talking about memory allocation and garbage collection, there's actually a video out there in that material that I did for you where it's talking about the destructor method. The destructor method that runs when the garbage collector comes around and gets rid of all the objects that have been deleted. Okay, so it'll talk to you about the memory deallocation and a reference count and all that. Might make more sense to you after you watch